This is the lab for GLBP. User network is 10.1.1.0/24. Action item number 1 is configure the default gateway using GLBP. The default gateway IP address must be 10.1.1.1. Router 1 must be the ABG and one of the ABFs. Router 2 to router 4 also must be ABFs. Router 6 must be willing to become an ABF but will not be participating in it at first. Validate the state of each router after configuring and validate how many virtual MACs are handed out. So let's configure here. Given the ABG process will not allow preemption by default, the first router that gets configured becomes the ABG. So let's do GLBP 0. I have to enter a group number. And the IP address will be 10.1 and priority will be 120. This is the priority to select the ABG. Remember that GLBP has ABGs, one ABG and up to 4 ABFs. So let's show GLBP, and the state, this router is the active for the ABG role. What else information we have? We have here the virtual IP address, the timers. This redirect timer and forward timer are used for ABF failures. Preemption is disabled for the ABG election. The active for the ABG is this router. The standby for the ABG role is unknown because there's only one router configured by now. The priority for the ABG is 120. The waiting for the ABF role is 100 by default. The load balancing is round robin. So far, we only have one group member, and there is one forwarder, which is active. We are active for this forwarder role. So there is one forwarder role so far in the network, and this router is active for that role. That means that this router is active for ABG, for the ABG role, and it is active for one of the 4 forwarder roles. So let's configure router 2, interface GLBP 1.1.0, GLBP 0, IP, and I probably want this router to become the second in line to become the ABG. So if we issue show GLBP for the role of ABG, it is changing its states. It should end as a standby. So it reached the conclusion that this router 2 is a standby because it has a priority of 110, whereas the active ABG has a priority of 120. So it is the second in line to become the ABG. Timers are the same. The waiting is 100 by default. Now the group members are 2 because I just configured the second router, and now we have 2 forwarder roles in the network. Forwarder number 1, for that forwarder, this router is in listening state. That means that if whoever has the forwarder role number 1 fails, this router will try to kick in and take over that role. And for the role of forwarder number 2, this router is active. So let's go and configure router 3. GLBP 0 IP, and we leave it as is. GLBP 0 IP, we'll leave it as is, and router 6 enters at the end. We don't want router 6 to become an AVF, so that's why we configure it at the end. So router 3 shows that for the forwarders number 3 role, router 3 is active. That means that router 3 is forwarder 3, but is willing to take over if one of the other forwarders um, have a failure. So for the other forwarded roles, router 3 is listening, and for the forwarded 3 role, it is active. So what happens with router 4 must be the same. Forwarder 4 is active for router 4 is active for forwarder 4 and is listening for any other roles. So now we have 5 group members. And what happens with router 6? It is listening for forwarder 4 role, listening for the forwarder 3 role, listening for the forwarder 2 role, listening for the forwarder 1 role, and listening for the AVG role. So it is actually not doing nothing. It is sitting there waiting for something to happen. And whereas we have 4 forwarders already active. So let's validate how the virtual MAC addresses are handed out. So the end devices are here. So originally they don't know what is the MAC address that belongs to the default gateway. So if we generate an ARP request, the AVG should be able to supply the corresponding MAC address, but with a little detail that the MAC address will change with for each app request. So that is the role of the AVG, trying to load balance the traffic among the forwarders. And how the AVG accomplishes that is by providing a different virtual MAC address to each device. Let's see the ARP cache here. This device believes that the default gateway has this MAC address that ends with 01, whereas this device believes that the default gateway has this MAC address that ends with 02. Meanwhile, this device believes that the default gateway has this MAC address that has 03. That is because the AVG is responding with ARP replies using different MAC address, each belonging to a different forwarder. So we can see that forwarder 1 has one ARP reply, forwarder 2 has one ARP reply, and forwarder 3 has one ARP reply. The load balancing method that the AVG is using is round robin. That means that for each ARP request, it will hand out a different virtual MAC address in a way that all forwarders have the same amount of virtual MAC address handed out. So if we ask again, let's clear the ARP here, and we ping again, we will be handed out a different MAC address that now corresponds to the forwarder. So round robin makes sure that each forwarder has the same amount of ARP replies. Another thing to notice here is that we can see the primary word here. That means that this is the router that took over the role at the first time. So let's go to action item number 2. Configure object tracking on routers 1 to 4. So that interface P60 goes down, subtract 1 from the weighting, shoot down pos 60 at router 4 and see how router 6 becomes an ABF. And then we'll have to answer the question, is router 6 a primary or secondary ABF? And what does a secondary means for GLBP? So let's configure that only on router 4. Doesn't make sense that we do it. And everyone, on a track, we're going to create a track object that will follow the status of the interface POS60 and the line protocol. So let's go to interface G10 and let's say that GLBP group 0 weighting should be 100, but the lower threshold should be 81, and GLBP 0 weighting flag. We will enable object tracking, decrementing 20 if something happens. So if we issue this command, we'll see that we have a weighting of 100 with a lower threshold of 81. We're tracking object 1. So if something happens, we will decrement this value of 100 by 20. So it will end up as 80, which is lower than the lower threshold. And when the weighting of an ABF becomes lower than the lower threshold, that router should give up the role. So let's go ahead and shut down the interface POS60, and we can see that the weighting is lower now. It is 80. It is lower than 81. So this router should give up being the forwarder number 4. So it takes a few seconds in order for that to kick in. So this state should change from active to maybe listen, and router 6 should change from listen to active. So let's wait until this happens. Okay, router 4 changes from active to listen, and router 6 changes from listen to active mode. So now router 6 is active for the role or for the forwarder 4. How the other routers see router 6? Let's issue this command, show GLBP, and the other router see router 6 as secondary. That means that it took over the role that somebody else had before. So that is what secondary means, that a router took over that role. So to answer these questions, is router 6 a primary or secondary ABF? It is secondary, and what does secondary means is that a router took over the role that some other router previously had. Restore the, let's go to action item number 3. Restore the network and configure load balancing as weighted. So router 1 and router 2 gets 2 times the traffic as router 3 and 4. So let's restore this. Let's make this interface not shut down. And meanwhile, we are going to make router 1 and 2 have twice as traffic as router 3 and 4. In order to do that, we are going to change the weighting. So on router 1, I'm going to configure GLBP 0 weighting 200 with a lower threshold of 181. And I'm going to do that in router 2 as well. So in this way, we will have a weight of 200 in router 1 and 2 and 100 in router 3 and 4. That means that is a double. Weighting 200, lower threshold 181. And also I'm going to change the load balancing method here to weighted. By default, it is round robin. That is what we were saying. It will load balance equally using each forwarder in turn. With the weighted load balancing, the load balance is made in proportion to the forwarder weighting. So we're going to choose weighted, So now if we issue show GLBP, we can see that we have a waiting of 200. Router 2 has 200. Router 3 has 100. And router 4 has 100. So now the load balancing is weighted. So now we're going to see how these stats regarding the ARP replies change. I'm going to create a lot of ARP requests and see how that ARP replies change over time. So I'm going to do a lot of clear ARPs and ping. So I'm going to pause the video and do about 12 or more pings. Hold on a second. Okay, now I have done this many times. Here ARP and ping the default gateway to generate several ARP requests. Let's see how the stats are doing. We started by having only one ARP reply sent, one for each forwarder. Now let's see how it is going with this different load balancing method. We have 4 forwarder 1 and 2, 6 ARP replies each, and 3 ARP replies for forwarder 3 and 4. That means that we are giving more weight to router 1, 2, and router 1 and 2, and effectively achieving twice the traffic that will be crossing through router 1 and 2. So this was successful. So let's go to action item number 4. Change the redirect timer to 60 and timeout to 660, and shut down router 6 and 4 and see what happens. These timers, the redirect timer and the timeout timers, kick in when an ABF fails. So we want to shut down router 6 because we don't want to take the role of router 4, and we want to shut down also router 4 in order to have an active ABF taking the role of another active ABF. So let's change the timers here. By default, we have these timers which are quite large. What I want to do is shrink them in order to see what happens in the lab. So I'm going to change them. This is only for lab purposes. The default timers are actually good. So this is only for the lab. GLBP 0 timers redirect. The lower, I'm going to choose 60 and 660. It's going to show me a warning. Let's issue for GLBP. It is now 60 for the redirect timer and 666 and 60. I'm sorry, 660 for the forwarder timeout. So let's now shut down router 4 and 6. So some of these routers should take over the role of router 4. Okay, I'm going to stop router 6 and I'm going to stop router 4, and let's see what happens. It should take some time before they figure out that router 4 is gone. State. So what happens here is that router 3 is active for 2 roles. So router 3 took over the role of router 4. Now when that happens, these timers start to kick in. See, redirection timer is already 23. It will continue to to 0. So when this happens, the network will still be using the MAC address that belongs to the failure AVF, and the AVG will still provide this MAC address until this redirection is on. And now that the redirection is disabled, AVG will no longer provide the MAC address that router 4 was handling. Now, this time to leave is the time that this forwarder slot will continue within the GLBP table. So once this reaches 0, this forwarder rule will be removed, and from the GLBP table. So this is the minimum value that we could set. So in theory, we should wait about 600 seconds in order to have this disappear from the table. I'm going to pause the video and see what happens when this reaches set 0. And something that comes to my attention is that you don't have a time to leave for the forwarder number 1. So this is a bit odd, and I want to believe that if the AVG is having the same role as the AVF, for that AVF there is no timing for the redirection or time to leave. So we are at 430 seconds before this time to leave reaches 0. So it's been about 10 minutes since we shut down router 4. Router 3 took over. The redirection disabled already has been reached, and we're going to see what happens when time to leave reaches 0. We're about 70 seconds away, and the deal here is that router 3 has been taking over this role. So router 3 is working for this MAC and this MAC, and the deal here is hoping that after this time to leave passes, all the devices that were using this MAC address are no longer in use. So that is what it is supposed to be 1 day long, but we just we reduce it in order to see what happens when it reaches 0. So this is done only for lab purposes, not to be done in real scenarios. So we are at 14 seconds in order to reach 0 for the time to leave. 9 seconds, 5 seconds, 2 seconds, and that's it. When it reaches 0, the role for forwarder 4 gets raised. That MAC address will be recognized by these routers, and it went from active to disabled. So forwarder 4 role no longer exists in this network. Okay, that's it.